Okay, this is on the file that says practice problems 2. Actually, I don't know if that's the name of it. It says second order ODE practice set 2, and this is like about midway through. I don't know why somehow kind of more advanced things or the things we covered second are first and that sort of thing. So this is practice set 2, and this is the third set of problems. Okay, and so the idea is we want to find the general solution to the following system. Okay, well, whenever you are presented with a problem like this, okay, whenever it is to find the general solution to a system, the step one is to go to Wolfram Alpha, and see what the eigenvalues or eigenvectors are. Okay, you don't have to use Wolfram Alpha. That's what I'm using because it's free and I kind of know how to use it. But whatever method, the first step is to find the eigenvalues and eigenvectors. Okay, so let's do that. So I've already done this for this matrix. It's 3 minus 2, 2 minus 2. This is the matrix. And one of the eigenvalues is 2 with eigenvector 2, 1. And another eigenvalue is minus 1 with eigenvector 1, 2. So let me copy that down. So minus 1, 1, 2. And then the other one was 2 and 2, 1. And we can verify 1, 2 times this matrix is going to be minus 1, minus 2. And 2, 1 times the matrix is going to be 4, 2. Okay, so these are eigenvectors. Okay, so that's step one. These are the eigenvectors and eigenvalues. Now we're going to assume that the general solution, this isn't like an assumption that's sometimes going to be true and sometimes not going to be true. The vectors that Wolfram Alpha spits out are going to be linearly independent. Okay, so x1 prime times x2 prime, this is equal to, x1, so let me back up here. So my assumption is that the solution x1 of t, x2 of t can be written in the form c1 of t times 1, 2 plus c2 of t times 2, 1. And again, any vector in R2 can be written in this way because 1, 2 and 2, 1 are linearly independent. And again, for this class, you're not going to have such a great understanding of what linearly independent means. I'm not asking you to have a great intuition about what linearly independent means. Kind of the principle, the thing that you need to understand is that the vectors, vectors are linearly, if you're in Rn, like we're in R2, a set of n or 2, in this case, linearly independent vectors, every vector can be written as a unique linear combination of those two vectors. That's what we use, okay? All right, so if you plug this into the equation, on the left-hand side is the derivative, and you're going to get c1 prime of t times 1, 2 plus c2 prime of t times 2, 1. This is the left-hand side, so it's the derivative part. And on the right-hand side is going to be the matrix times that vector. Okay, so this is going to be c1 of t, the matrix 3 minus 2, 2 minus 2 times 1, 2 plus c2 of t times 3 minus 2, 2 minus 2 times 2, 1. Now the whole reason we are writing the solution vector as a linear combination of the eigenvectors is because this has a very nice formula. This is going to be minus 1 times c1 of t times 1, 2, because the matrix times that vector is equal to minus 1 times 1, 2, plus 2 times c2 of t times 2, 1. And again, it's because the matrix times the vector, 2, 1 is an eigenvector with eigenvalue 2, so this matrix vector multiplication is going to be 2 times 2, 1. Okay, and so what we have is that the left-hand side, this is the left-hand side. If x1, x2 is a solution, the left-hand side is equal to the right-hand side. Okay, now we're going to use the fact that these two vectors are equal. Since the vectors 1, 2, and 2, 1 are linearly independent, what this tells us is c1 prime of t is equal to minus 1 c1 of t, and c2 prime of t is equal to 2 C2 of t. Okay, great. So we know that the general solution to this first equation is going to be C1 is equal to A1 times e to the minus t, and C2 is equal to A2 times e to the 2t. Okay, these two differential equations here, this one and this one, we're so-called experts at solving this now. This is what we did in chapter 2. Okay, so this means if you plug that up into this formula for x1 and x2, what this tells you is that x1 of t, x2 of t is equal to c1 of t. The solution to this equation for c1 of t, the general solution, is a1 times e to the minus t, and we're going to multiply this by 1, 2, plus c2 of t. c2 of t, the general solution for this equation, tells us that c2 of t is going to be a2 e to the 2t, and we multiply it by the vector 2, 1. So there you have it. That is a solution to this system of differential equations. That is the general solution to this system of differential equations. And if we add in an initial condition, we could use that to solve for a1 and a2.